Okay, so another one, we're moving into section 1.3, the last section we're going to cover in chapter 1. I think the beginning of this is a lot of, let's call it maybe table setting, where there's a lot of vocabulary. We've hit most of it that's going to be most important to us. 1.1 has all that stuff about population, parameter, statistic, sample, and so forth. We're going to use that language a lot. Stuff about quantitative and qualitative data, discrete and continuous, we're definitely going to use that a lot. There's a couple ideas in 1.3, the beginning, that this video is going to be about, that are a little less important to us in the sense that they don't come up as often, though when they do, they can be important. But then the second half of this section does actually, we start to get into some of the meat of this quarter with some really important stuff. So I'm going to make a different video for the second half. So I'm just going to do the last little bit of, say, vocabulary and table setting. First is going to be a comment about rounding. So we're just going to make a general rule of thumb. I'll give instructions as needed in particular problems here and there, but without instruction, what's usually safe to assume is that your final answer would have one more decimal place than what was given. So, for example, well, I'll give an example in a second. You'll have one more than given, and the other piece of advice or rule we should adopt is that we round at the end if possible, right? So if you're using a calculator, you can keep those answers that might have 7 or 8 decimal places in there as you work, if possible. Or if you're using a computer, of course, then it can keep a lot more decimal places than that. And I'll give an example too of why that's important. So let's do those now. So first of all, just a quick example of, let's suppose a student had 3 exam scores, let's say an 84, a 93, and a 97. If we wanted to compute the average of these exam scores, I'm going to use a symbol you guys haven't seen yet. We'll talk about this later. Just this little X bar to be the average, and the average we would compute by adding the 3 together and dividing by 3. And when we do this, we get 91.3, right? This is actually an approximation. The 3 goes on forever. But this is an example of just rounding to one more decimal place than the scores given, right? So that's a typical rule of thumb. No big deal there. This one's a little bit, the other idea is a little bit trickier. The idea about rounding at the very end. So let's consider the following problem. Suppose I gave you had a square of material, and I asked you its area, right? So how do you figure out the area of a square? You measure the side, and the area is going to be s squared, right? Whatever the length of that side is. So let's say you measured it, right? And let's say I told you to, we're going to measure in centimeters, give area to the nearest square centimeter, right? Or sometimes people use the symbol centimeters squared, okay? So in other words, I'm going to round to the nearest whole number, okay? For the area. So let's say you measure it and you determine that it is 9.9 centimeters, right? So your best ability to measure it gives you 9.9 centimeters. So you might compute s squared as 9.9 centimeters squared. If you work this out, you get 98.01 centimeters squared. And then according to my instructions, I said round it to the nearest square centimeter. So we would say this is about 98 centimeters squared, right? We changed it very little. We rounded this little 1/100th of a square centimeter. On the other hand, let's say you measured it and got 9.9 centimeters and thought, oh, we're rounding it to the nearest whole number, the nearest square centimeter. So I'm going to round this to 10. So this is an example. Let's do this separate. Let's instead say I took S and said, well, it's close to 10. I'm going to round to 1 decimal place early. And then I'll compute the area. I get 100 centimeters, 10 centimeters squared, which is 100 square centimeters. Notice that our answer now is off by a lot more, right? We rounded by 1/10, but when we square it, that 1/10 error gets worse, right? And we end up being almost 2 centimeters different than the actual answer, right? So this is what happens when you round too early. This is one of the things that can happen. That error gets exaggerated, okay? So this is why we say round at the end. And so you want to either be writing those values down or preferably using a calculator or computer that can store, right, that you can keep those answers with all those decimal places in there and then round at the very end. Okay, so let's, all right, so then that was just a word on rounding. The other thing we're going to do for this first half of this section is our last little bit of, not our last vocabulary for the quarter, but we've got one more bit of vocabulary to do here for something called levels of measurement. Right? So we can go out and measure things, right? So we can think of measurements here as collecting data. We get data, and we want the levels of measurement is sort of a way to say, what can we do with the data that we get, okay? So we're going to start with kind of the weakest level of measurement that we can do the least with and get increasingly high levels of measurement. So we're going to start with what is called nominal data or a nominal measurement, right? This is going to be qualitative, and it's only going to be labels or names, right? No calculations, right? We can't take these things and calculate them, okay? So what do I mean by qualitative? Well, that's the same thing we meant before, qualitative data, right? It's not going to be numerical, it's going to be some kind of category. So if I wanted to poll you guys on your favorite brand of coffee, those brands would be our categories, right? I can't do any calculations. I can't take the average brand by adding Victrola plus Starbucks and dividing by 2, right? That doesn't make any kind of sense. So let's move up a level from nominal to what we call ordinal. Ordinal. It's still qualitative, but it has a meaningful order. Right? There's still no calculations. So for example, let's put some examples over here. Here we had, say, coffee brands, maybe country of birth. Right? Well, sometimes qualitative can still have an order. It's not numbers, but we can put that in order. So for instance, if you are, we talked about this in one of the earlier videos, if you were rating pain, right, you might get a scale that's something like none, mild, some, and extreme or something like that, right? So we're getting more and more pain as we move to the right. Or maybe when you do evaluations for the course, right? Or any classes you've been in where you have to do those course evaluations, you might be asked to rate your instructor's performance, and you might have some kind of rating like poor, I don't know, unsatisfactory, satisfactory, and excellent, right? Something like this, where you're going from the worst to the best, right? So you still can't calculate, I can't take the average of satisfactory plus excellent and divide by 2, but they're at least in order, so we get a little more meaning out of them, okay? So then we move into interval, which is our first level that has quantitative data. And here, Differences are meaningful. I'll explain what this means in a second. Are meaningful. Ratios are meaningless. Right. And we also sometimes say there's no 0 point. So let me explain what all of this means. Okay. So actually, let's come back to that one. I think it'll be easier to explain in comparison to this other one. So let's hold off on interval and let's go to our highest level, which we call ratio. And this is also quantitative. It has order, it has ratios, it has a 0 point. Okay. So let's do some examples of interval versus ratio. Okay. So a good example. Do interval over here and ratio over here. An easy example of ratio would be something like, suppose some child at some age is, let's say, 52 inches tall, and another child, a younger child, is only 26 inches tall. It makes sense to say that this child is twice as tall as this child. That's a sensible ratio, right? To say that they're twice as tall, right? This is related to the idea of a 0 point in the sense that 0 inches tall, there's no height. There's an actual thing that there's none of, right? When the 0 point actually means there's none of something, then it does actually make sense to have ratios. Let's look at a situation where it doesn't. Let's compare 2 days. Maybe there's a day that has a high temperature of 20 degrees Fahrenheit, and there's another day that has a high temperature of 40 degrees Fahrenheit. It's certainly the case that 40 is twice as big a number as 20. That does not mean that 40 degrees Fahrenheit is twice as hot as 20 degrees. Right? Maybe one way to see that you might feel like that is the case, right? I know when I've talked to people about this in person, it feels like that should make sense. But let's do a quick conversion. If I convert these to Celsius, we're talking about the same temperature with just a different label. 20 degrees becomes negative 6.7 degrees Celsius, and 40 degrees is 4.4 degrees Celsius, right? Same temperatures, different labels attached, right? Is 4.4 degrees twice as many as negative 6.7? And now it doesn't seem like that should mean anything, but nothing's changed about what these temperatures are. The problem with both of these scales is 0 degrees doesn't mean 0 of anything. It's randomly picked, okay? It doesn't mean 0 of anything, right? What temperature is measuring heat at 0 degrees Fahrenheit and Celsius, there's still heat. 0 is just picked arbitrarily at some point. This won't be a huge issue for us, but it is kind of an interesting thing to note that just because we have numbers doesn't mean every kind of calculation we can do with some numbers makes sense to do for all of them. Okay, time is another one. Is 4 p.m. twice as late as 2 p.m.? Right. Well, it depends on what time you were supposed to get there. If you were supposed to get there at 9 a.m., right, then if you were supposed to get there at 9 a.m., then 4 p.m. and 2 p.m., well, what does this mean? It's 5 hours late, and this would be 7 hours late. It's certainly not twice as late. On the other hand, if you were supposed to get there at noon, then 4 hours after noon is definitely twice as long as 2 hours after noon. So if it just depends on where you pick that 0 point, right? The 0 point in that case is 0 hours late. So it depends on what it means there. But the numbers 2 and 4 don't really tell us anything about that. Okay. Okay, that's all we're going to say about that part of the chapter. I'll make another video in a little bit for the second half where we do get into the meat. We start talking about frequency and relative frequency, which are going to be things that we talk about quite a bit throughout the quarter.